This is a Wilo brain box. This is going to show you basically a common everyday heating system, and it's going to show the energy efficiency between a standard speed circulator and our variable speed circulators. Right now we're hooked up to our variable speed, our standard speed circulator, which is our star 21 down there on medium speed. You can see we're moving about 6 gallons a minute through this circuit and about 1 gallon through this circuit. So we're moving roughly about 7 gallons around the board right now through our heating system. We're using 67 watts of energy, and we have our head set point is just under 2 bar, which translates to about 6.6 feet of head. Typically in your heating system, what would happen is your zones start to satisfy as the house comes up to temperature. So we're going to turn off our zone valves in the heating system. See, a couple things happened here. Our velocity went up considerably through the piping, so we're getting a lot of noise. The other thing that happened is you'll notice our head pressure rose from the 2 feet bar to about 4 bar, which is about 13 feet ahead. We're asking the pump to do less work, and it's actually working harder at this point. We are still using about 56 watts of energy. Now we'll take this down to our micro zones, as we call them. This may be your small radiant zone in a master bathroom somewhere, or a small breezeway zone. So we're only moving about a half a gallon a minute. You'll notice that we are almost deadheading the pump. We're almost at the max of 16 feet ahead for this pump, and we're still using about 54 watts of energy. Again, we're asking the pump to do its absolute least amount of work and load, but yet the pump is working it the hardest it can possibly work. Something we never do, we're deadheading this pump completely. There's no flow in the system. Circulator will not last very long. Working that way, it's going to burn up and kill the pump. So what we'll do is we'll shut that one off. I'm going to switch over my pressure hose here so I can see what my other pump will be doing. You'll notice something when I do turn the switch on. Nothing is going to happen right off the bat because this is a soft start motor in this pump. The hard start in a regular circulator does use more energy than you think. So we, sure my valves are open, have the soft start motor. So we gave the pump power, and you'll notice it comes on, it comes up, peaks out a little bit, and it will settle down. Right now the pump's finding its curve where we set it. We set the pump to about 5.5, 6 feet ahead on the setting, which, as you can tell, the pumps, these two pumps are set exactly the same. They're moving the exact same amount of water. We're moving a total of about 7 gallons a minute around the board. Right off the bat, the biggest thing you'll notice is before we were using 67 watts of energy, we're now using 27 watts of energy. Our zones start to satisfy again around the house. We start reducing our flow through the heating system. You'll notice one thing that did not happen with this variable speed circulator is our head pressure actually dropped. We're asking the pump to do less work, and right now we're only drawing about 6 watts of energy. And we're going to take us down to that little micro zone again, the master bath radiant. We're moving about a half a GPM. The other thing you'll notice, again, our head pressure went down even further. We're asking the pump to do less work. It's doing that, and we're drawing 5.3 watts of energy. And that is our energy efficiency savings on electricity and the variable speed circulators.